The focus of this lesson is on graphing by transformations, in particular stretches and compressions. So when we talk about stretching or compressing, we are having a situation where we have our parent function, but there's a multiplier on that parent function. And that multiplier may be on the entire parent function, and in that case that would be a vertical stretch or compression. Or the multiplier might be on the x value, and that would be a horizontal stretch or compression. And then depending on the value determines whether it's a stretch or a compression in both the vertical and the horizontal case. So we're going to go ahead and just start off with the parent function. So the parent function is f of x equals x squared. And again, we just graph our parent functions point by point, and you probably have these functions down from your library of functions in 2.6. So if you do, that's fine, but notice you want to pick a negative value, your vertex, which is at 0, and a positive value. So I usually pick -1, 0, and 1. Now if I square each of those x values, -1 squared is 1, 0 squared is 0, and 1 squared is 1. That'll give me my three ordered pairs. And then I need to plot -1, 1, 0, 0, and 1, 1. Notice this is similar to the absolute value function, except it's more U-shaped versus V-shaped. So that is our f of x. So that's just graphing the parent function point by point. So then now I need to worry about the type of transformations I have. So I'm going to go ahead and take a look at our first function, g of x, which is 5 times the x squared. So I'm just going to kind of break that up so you can kind of see that. So there's a multiplier. So I know I'm dealing with that stretching or compression. So it's 5 times my original function, which is f of x. So it's 5 times the y's. So I know that that's a vertical concept because the multiplier is on the whole function, the y's. And it's going to be, since the value is 5, it's going to be a stretch by 5. Exactly what you would expect. Okay. So we would take our function, and each of the points will stretch vertically, so in the y direction, by 5. So they'll move up. So instead of being at 1 unit, it's now going to be 2, 3, 4, 5 units. At 0, 0 times 5 is still 0. Instead of 1, 1 times 5 is 5. So that pulls you up. So you can see that you have the same graph. It's just stretched vertically by 5. So that's g of x. Let's go ahead and look at k of x. K of x is 1/5 times x squared. So 1/5 times my original function, which was f of x, or x squared. So again, the multiplier is happening to the entire function, to the y's. So that's a vertical concept. And the multiplier was 1/5, so it's going to be vertical by a fifth. But since that value is less than 1, 1/5 is less than 1, that's going to be a compression. So it's vertical compression by 1/5. So in other words, it's going to squash down. So instead of being at a height of 1, we're now going to have a height of 1/5. Now 0 times a fifth isn't going to change. It's still 0. And then 1, if your height is 1 times a fifth, is at 1/5. So you get this graph that's kind of more squashed. So that's your k of x, and that's a compression by 1/5. So notice your vertical stretch and compression come from a multiplier on your f of x, or on your entire function. And if the value is bigger than 1, it's going to be a stretch. If the value is less than 1, it's going to be a compression. Now let's go ahead and take a look at L of x. So L of x is 5x, that whole quantity, squared. So similar to our original function, but instead of having x squared, 5x is squared. So that's our function evaluated not at x, but at 5x. So you can see that there's a multiplier of 5 on the x's. So when it happens on the x's, we know that that's a horizontal case. And for the horizontal, think reciprocal of your multiplier. So my multiplier is 5. The reciprocal of 5 is, just flip it, is 1/5. So since that value is less than 1, that's a compression. So it's a compression by 1/5. Okay. And so what that means is what we had for our graph here in black, our f of x, horizontally we're compressing and squashing down by 1/5. So instead of being out to the left by 1 here, we're going to be out to the left by 1/5. Instead of being out to the right by 1, we're going to be out by 1/5. And then the vertex is at 0 as far as a horizontal movement is concerned, and 0 times 1/5 is still 0. So that doesn't change. So horizontally your graph is squashing, and I know it's kind of getting all cumbersome over here and hard to see, but we are squashed down horizontally, like kind of accordion style. Let's take a look at m of x. M of x is 1/5 x, and then that whole quantity is squared. So again, similar to our parent function, f of x is x squared, but what is being squared is different. It's not x, it's 1/5 x. So this is our parent function evaluated at 1/5 x. So the multiplier is on x, so I know that that's horizontal. And then think reciprocal for the horizontal cases. So the reciprocal of 1/5 is 5. And since that value is bigger than 1, that's going to be a stretch by 5. So don't consider whether it's a compression or a stretch until you've dealt with the reciprocal of a horizontal stretch or compression. So we would take our function f of x, which is here in black, but stretch it horizontally, so to the left and right. So instead of being at 1 here, multiply that by 5, that's going to put you out here at 5. Well, in this case, -5. Instead of being at 1 here, if you multiply by 5, that's going to put you out here at +5. And then if you multiply 0 by 5, it's still 0. So notice the vertex didn't change. But you're stretched horizontally, and you can kind of see that your graph is pulled out horizontally. And I know that's not a perfect drawing, but that's our m of x. So that completes this lesson on stretches and compressions. Notice again, if your multiplier is on the f of x's, it's vertical. If your multiplier is on the x's, it's horizontal. If it's a vertical movement, just take the number as is, and that'll tell you whether it's a stretch or compression. Stretches are bigger than 1, compressions are less than 1. If it's horizontal, you're going to think about the reciprocal, and then once you've got the reciprocal in mind, if the number is bigger than 1, it's a stretch. If the number is less than 1, it's a compression.